Irrational numbers. These are numbers that cannot be written in the form of p by q. So let me clear all the doubts, because I'm sure you will be wondering what are these numbers, which cannot be written as fractions. Root of 2. Yes, we can write root of 2 as root of 2 divided by 1, but we need to solve root 2 first. I want a particular number which gives me the value of root 2, the operation of root 2. So let's see why root 2 cannot be, written in the form of p by q. See, root 2, if you look at it, the actual value is 4.1.41421356, so on and so forth. So one thing is, it is not going to stop. Okay, yes, my calculator has ended it, but if you take a bigger calculator, it will keep going. If you take even bigger, it will keep going. So it will keep going. If you take supercomputers, it will never stop. If you put it in computer, so there's if you program it and let it be, it will run forever. So answer is root of 2. So this number cannot be written in the form of p by q. So basically any number that is non-terminating, that is never ending, and non-recurring. There's no pattern that is recurring. So when we tell recurring, it's not about numbers like 3 is occurring everywhere. 3 over here, 3 over here, 8 is occurring a lot of times. Is it not? It's not about that. It's about not repeating. Okay, so anything that is non-terminating and non-repeating, there's no pattern, right? No pattern. So if you don't see any pattern, that is non-terminating, non-recurring. Okay, so let me summarize non-terminating recurring and non-terminating non-recurring, because if I make this clear, then I guess things will be a lot easier. I'll take an example 1 by 13, right? And here I'll take root of 13. So let's divide 1 by 13. So let's see, this is one thing is it's non-terminating. It'll never stop. You can never stop dividing it. But it is recurring. So let's see what is recurring. See, 13 is a very odd number. I mean odd in the sense non-2 or prime number basically, right? It's one of the prime numbers. So dividing with 13, 17 and all, it's something which you guys are scared of. Is it not? So that's why I took this number. So we can see here that such a number which is neither 2 or 5 will give us this. What is this? We have 076923, right? That's the pattern you can see over here. 076923, 076923, again 076923, 076923. So you can see that 076923, it keeps coming and coming. If you have a bigger calculator, that pattern will keep going. So basically 0.076923 will keep repeating, right? Remember the bar indicates that this particular set of numbers will keep repeating. It will never stop. That's what it indicates. And instead of writing so many times, you just put this and tell. You can never write it actually. I mean, even the calculator is not able to write. You just end it. Right? So this is your recurring. This part is recurring. While root of 13. Let's see that. 13 and root of that. We can see over here, it's neither stopping. Again, my calculator stopped it, but if you keep continuing to divide, it'll keep going, and there's no pattern. Right? You can tell such 3 5s came. It's not about that. It's something like this, set of numbers coming again and again. You can check it out, it will never come. So this is your example of non-terminating, non-recurring. Okay, to summarize, we have this. So the very first classification of numbers is natural numbers. 1, 2, 3, till infinity. Above that is your 0, 1, 2, 3 till infinity. Above this is your integers. Integers is made up of positive integer, 0 and negative integer. Right? This is how we can classify integers as. So when we talk about positive integers, it is same as natural numbers. When you talk of 0, well, it's 0 itself. When you talk of negative integers, it is minus infinity to minus 2 minus 1. Right? So above integers, we have rational number. So integers is part of rational number, and rational number also has also has fractions. So this kind of fraction can be further classified as, the fractions can be further classified as terminating and non-terminating but recurring. So terminating is one which stops, like 14 by 16, right? Such numbers, it will stop the division. 14 by 100, 0.14. And non-terminating but recurring is 4 by 3, 10 by 17. All these are non-terminating, non-recurring. Opposite of your rational number is irrational number. So which is non-terminating, right? And non-recurring. So there's no pattern that we see. Root of 143 is one example. So containing both this rational number and irrational number is your real number. Okay, so that's how we classify. So let me repeat the entire thing. We have real number. Under real number, we have irrational number and rational number. Under rational number, you have integers, and under integers is your whole number, and under whole number is your natural number. The one which is opposite of real number is imaginary number, which is not part of your syllabus, but it's for your knowledge. So all these numbers, right? Excluding these numbers, you have one more set of numbers classification, that is imaginary numbers. Okay. So this is the end of your introduction to classification of numbers. Pause and whatever you feel like writing, do write it. And one thing is, you need to know all of this. It is important. Know all of this, know the classification, understand it very well. And we'll be understanding this a lot, all of this in detail again. But yeah, you can make a note of it in your formula list. That's my suggestion. Please enroll to our program at chalkpieceacademy.com, wherein we'll be teaching you a lot more tricks for faster simplification calculation, DIY projects. We'll code with Python. We'll work with Arduino Uno. There are a lot more magic tricks and the physics behind it. They are printable materials which will help you recap and understand things better. We'll have live revision and doubt session 2 months before your term exams. It's very cost effective. There would be no ads or any kind of distractions, and we have a dedicated app to help you guys with this.